Hello and welcome again to SQL TV. This time I want to talk about data warehouses. What is actually a data warehouse? Why do I need it? And this will be a little series of videos. What different kinds of data warehouses are they and where are the advantages, disadvantages, what is old, what is rather a new model or technique, and then we can discuss this in the very end of this series. So this time I want to start with what actually is a data warehouse, and since we talk a lot about SQL here on SQL TV, basically one main application for applying SQL is either in transactional databases or in BI environments where you often find data warehouses, staging areas and data marts and so on and so forth. So this time I want to talk about what actually a data warehouse is. So you have to imagine the following situation. You are situated as a SQL developer in your company's C1, let's call it just C1, and we are in headquarters. So we are in headquarters and we have different subsidiaries all over the world. And suddenly there's a new guy in management and he wants to really be a guy that brings the numbers to the tables and change the whole company and so on, and for this he needs data from us. So he comes to us and says, hey, can you tell me what is actually our top 10 selling products? What are our top 10 selling products by quantities, by margin, by whatever values or measures he wants to have. And we have now to get him the data. So now our problem is the data is not at headquarters yet, the data is in the subsidiaries. For this example, we just assume that we have two subsidiaries, one in the US and one in Germany, because they will have some differences and we have to tackle them. So we have two subsidiaries, one in Germany and one in the US, and we want to make sure to bring the data to headquarters. The problem now is that we find out that those subsidiaries store their data completely different. We want to get invoice data, we want to get invoices so we can say that's what we sold, that's the article we sold, that's the money we got from the sales, and so on and so forth. And for this reason we have to bring it all to headquarters, because of course Germany and US can sell the same product. We have to sum up all the data and aggregate them on a total level so that we can make reports and tell our new management guy what is going on in the company. So I will just sketch out how those two subsidiaries may store their data locally on their systems and how we have trouble bringing this all together. So let's start with the US. Let's say they have a table, they have some Excel file where they store their invoices, and they have a quantity column, they have a table and they have a quantity column, a price column, an article number column, a sales date column, and a tax rate. For now this is enough for our basic reports. And now we just make a sample sale for this and to show you how the data is stored. And don't be amused by this fact of Excel files. This is quite, it can still happen often that companies, or even not so small ones, still store their data in very strange way, believe me. So let's just make a sample sale. Let's just assume we have 1,000 quantities. We sold it for a price per article $5, and the article number is 4711. Remember, this is an internal article number. This is no barcode, no UPC, no EAN code or something. This is just something internally, which we also print on the products. And this is some sales date. I will just skip it here because we don't need need this for our investigation here. And the tax rate may be 0.2%. So as you can see, this is all good and fine. We have some rows here, and now let's have a look at the German subsidiary for how they are storing the data. So let's just assume the Germans, they have some kind of database system. Let's say they have an IBM DB2 system where they store their data. It doesn't really matter where they store it, and then they have a sales sample, like they have 1,000 quantities, they sold it, and now they store the net price, but not per article but per the whole line. So they say, okay, we sold 3,000 net for net price in euros. The AN code is A. The sales date is irrelevant for us now, and the cross price would be also on line level 4,000 euros. So you see already you have trouble when you want to bring those data together. When you want to bring those data together, first of all, the 4711 and the article with the EAN code A should be the same article, okay? So the first problem you have to tackle is to somehow map this kind of stuffs, because you need some table where you see that what the external codes, the EAN or UPC barcodes, are mapped to your internal article numbers and what article this is. And for this reason you need some kind of master data database where you have an articles database where you store everything. So you need to bring not only the Excel file somewhere to your headquarters, you also don't only bring the German data to your data warehouse, because this in the end will also all go into your data warehouse. You will also need to bring something like article master data from your company. Maybe they also stored in Excel files or even worse, and then you can combine all those data together, because what we want to achieve is we want to find out, okay, this is the same article as this, and then we have to calculate. First of all, you see different currencies here, dollar and euro, of course, because the different countries sell and buy in different currencies. Then the second problem you face is that we have here no price per article. We have here a cross price and no tax rate, and here is the tax rate explicitly. So we have to calculate something. So the first attempt could be that you take data from here, you take data from here. You just bring it one-to-one into your data warehouse in a US invoice table and a Germany invoice table. If your manager comes and wants to see some reports, you just create some code to tackle this and this data one by one. Problem here is if the manager comes with 20 or 30 other report requests the next few months, you always have to evaluate this data and to rewrite your code for each report. This is actually not a good idea, because there will be more than one report and request on this. So the better idea is to harmonize the data, to unify it in this manner so that we can store it here. We still see where it came from, but we can also already compare the data. And I can show you on the small example of those two cells how we can achieve that. So for our example, let's just assume that we want to combine our articles on the article number. So we have some mapping table that tells us that 4711 actually is EAN code A. So for our final table in our data warehouse, where we store all the subsidiary data, no matter if it's from US, Germany or some other different country, we want to store the quantities, we want to store the price per article, and this is the net price per article. We want to store the tax rate. We want to, for this line of course, we want to store the article number. We want to store the subsidiary ID, because of course we have to distinguish from which subsidiary it came from in order to make area reports on what the top 10 products by area, for instance. And we need of course the currency code, because this is here implicitly clear what currency it is, but it may not be clear if we combine all of the world's data what currency we have. So our sales would combined would be now the following. So for the US it would be actually very simple. We have 1,000 quantities, we have the $5 price per article. This was already the net price in the Excel file. We take the tax rate from 0.2, we already have it from the Excel file. We take the article number, which we also already have. Then the sales date I just left out here. Of course we want to store also the sales date. We want to know when the sale is in order to make reports on the last quarter and stuff like this. And we have a subsidiary ID 1. We just have to map of course this ID to in another subsidiaries table. And we have a currency code US dollar, which is very important in order to identify our revenue when we multiply this all together. So this is easy for the US. Now let's come to the German entry. The German database, we have to also take the 1,000 quantities. We have now to calculate the net price is already on the line sum. So we have to divide it by the quantities in order to get our €3 price per article. We of course entered this as euros here. The tax rate we also have to calculate. We have to divide gross by net price in order to get those 1/3 of tax rate, so 0.33% tax rate we have here. We have to calculate this for this subsidiary. The article number we could map, because I told you already we want to have the A as 4711 in our article master data table. And so it said again, I didn't put it here, but of course we have to also store the sales date. you have to take this over, and the subsidiary ID in this case is 2. Of course, this has also to be mapped again in a table that's called something like subsidiaries or whatever. So here you have it, and on this we cannot make any evaluations for the total, but on this we can. On this we can easily group by the article number and multiply quantities times price per article and plus 1 times 1 plus tax rate. Then we get the whole sales amount, and then we can group it by article numbers or by subsidiaries IDs or by sales dates. So we can make whatever evaluations what the manager wants us to do now on this table, and we don't need to be worried about how the subsidiaries are storing their data locally. So basically you bring all data from all the world together, you harmonize it, that you can use it in one table or in one big aggregated fact table or something like this, and then you can make whatever reports you want to do on this table. Basically this is a very basic approach of a data warehouse, and you already heard it. You don't only have sales data, you will have some orders, you will have some inventories, you will have some article master data, you will have some other stuff. You all have to combine this in one central data warehouse where all your data is stored in a harmonized way so that you can really do anything with this data. So this is basically the concept. The open question now is basically how you want to structure this. This is just a theoretical high-level approach on our situation, but there are very specific ways on how to store data. So the 3 most used ways are the third normal form data warehouse, is probably the oldest one by Innen. Then we have the star schema data warehouse, which is basically a Kimball approach on how to store the data, and we have a new or more modern approach that is on the rise. It is a data vault data warehouse, which also is a complete different paradigm. So in the next 3 episodes we will have a look on these 3 modeling approaches, and we will have some pros and cons about it, and we will have some examples there. So see you next time when we are talking about data warehouses part 2. Thanks and bye.